Imagine pulling back from Earth. First you see the blue marble in space. Keep pulling back and the continents fade from view. Go further and our planet shrinks into a bright dot orbiting the Sun. Keep going and the Sun becomes just one of hundreds of billions of stars in the Milky Way. But we are not done. Zoom out more and even the entire Milky Way becomes just a speck lost among countless galaxies. Now here is where things get weird. These galaxies, they don't just float around randomly, scattered like sprinkles on a cake. No, they arrange themselves into massive structures. Cosmic highways stretching across the universe. Filaments of light, galaxies strung together like pearls on a thread. And in between? Vast empty voids, oceans of nothingness, spanning hundreds of millions of light years. Astronomers call this astonishing structure the cosmic web, the largest, most intricate pattern in the universe. And it's not just for show. This web is the skeleton of the cosmos, the framework upon which galaxies, stars, and planets, and ultimately us, came to exist. The discovery of this cosmic web shook astronomy to its core. For centuries we thought the universe was uniform, that galaxies were sprinkled randomly in every direction. But when we mapped the heavens with greater precision, we uncovered something far more profound, a hidden architecture. So here is the big question. How did the universe build such enormous structure? What mysterious forces guided galaxies into these filaments, leaving behind colossal voids? And if we could zoom all the way out to see the entire web, what would it look like? The story of the cosmic web begins with a simple idea. Map the galaxies. For centuries, astronomers catalogued stars and nebulae by hand, little more than dots on parchment. It wasn't until the 20th century that telescopes and photographic plates began to reveal the true scale of the universe. Galaxies beyond our own, each an island of billions of stars. But here is the catch. Those galaxies weren't evenly distributed. Some seemed to clump together, forming clusters. Others seemed to avoid vast stretches of space, leaving behind dark, empty voids. At first, scientists thought it was just a coincidence, a random chance. But the deeper we looked, the stranger it became. The turning point came in 1980s with the CFA redshift survey. For the first time, astronomers weren't just counting galaxies, they were measuring their distances and charting them into 3 dimensions. What appeared on the maps stunned everyone. Instead of chaos, the data revealed walls, filaments, and voids like some vast cosmic honeycomb. One of the most famous discoveries, the Great Wall, stretches over 500 million light-years across. That's 5 million Milky Ways lined up edge to edge. Then came the Sloan Digital Sky Survey, armed with advanced telescopes and computers. Suddenly, astronomers could map hundreds of thousands, then millions of galaxies. Each new survey added detail to the picture, and the result was breathtaking. Galaxies forming delicate threads, weaving together into an interconnected structure. Humanity for the first time had seen the skeleton of the universe. And here is the kicker. When you look at these maps, the scale is almost incomprehensible. These filaments span billions of light years, yet they are made of galaxies. Each galaxy filled with billions of stars. It's a fractal of unimaginable proportions. This discovery changed cosmology forever. It wasn't just about cataloging galaxies anymore. It was about understanding the hidden forces shaping the cosmos. Why do galaxies follow these patterns? Why do voids exist at all? And what invisible hand is sculpting this giant web? The answer points to one of the universe's most elusive players. Something that doesn't shine, yet makes up most of the cosmos. The answer begins with dark matter, the invisible scaffolding of the universe. We can't see it, we can't touch it, but we know it's there. Galaxies spin too fast to be held together by visible matter alone. Something unseen is pulling the strings, providing the gravity needed to shape not only galaxies but the universe itself. Imagine dark matter as an invisible 3D framework stretching across the cosmos. In the earliest moments after the Big Bang, it began clumping under the pull of gravity. These clumps form the skeleton and normal matter. The kind that makes up stars, planets, and us simply followed the outline. Over billions of years, gas and dust collected along the dark filaments, forming galaxies. The result? A universe that looks more like a vast spider's web than a random spray of stars. But what about the voids? These are the opposite of the filaments, vast regions almost completely empty of galaxies. They exist because gravity pulls matter towards the filaments, leaving behind enormous bubbles of nothingness. Some of these voids are hundreds of millions of light years wide, whole regions of space where you could travel for eons and never see a single galaxy. Think of it like soap bubbles pressed together. The thin walls between them are where galaxies collect. The hollow interiors? That's the voids. The pattern is eerily familiar, like nature's geometry repeating itself on scales from microscopic to cosmic. And here is where it gets fascinating. Computer simulations of the universe starting from the Big Bang naturally produce this web structure, but only if dark matter is included. Leave dark matter out and the web never forms. That makes the cosmic web one of the strongest pieces of evidence that dark matter is real, even if we still have no clue what it actually is. So the web is more than just beautiful. It's a cosmic fingerprint of the hidden forces shaping everything. But how do we actually map something so vast? If you made it to this point of the video, it's a perfect moment to hit the like button and subscribe to our channel. It's free and it helps our mission. If the cosmic web is the largest structure in existence, how do we actually see it? After all, galaxies are faint, scattered across unimaginable distances. Mapping them requires both clever technology and patience on a cosmic scale. The first tool astronomers use is redshift. As galaxies move away from us with the expansion of the universe, their light stretches toward the red end of the spectrum. By measuring that redshift, scientists can calculate the galaxy's distance, plot enough galaxies in 3 dimensions, and suddenly patterns emerge. Filaments, clusters, and voids begin to take shape. Surveys like the CFA Redshift Survey and the Sloan Digital Sky Survey pioneered this technique, charting millions of galaxies and creating the first true maps of the cosmic web. Today, projects like DESI, Dark Energy Spectroscopic Instrument, and Euclid, the European Space Agency's newest space telescope, are taking this even further. Euclid launched in 2023. It's designed specifically to map dark matter and dark energy across billions of light years. Think of it as Google Maps, but for the entire universe. But redshift isn't the only trick. Astronomers also use gravitational lensing, the bending of light caused by massive objects like galaxy clusters. By studying how background galaxies are distorted, scientists can trace the invisible distribution of dark matter itself. This doesn't just show where galaxies are, it reveals the hidden scaffolding of the cosmic web. And then there is the cosmic microwave background, the afterglow of the Big Bang. Small ripples in the CMB act as the blueprint for how matter clumped together in the early universe. When simulations use this data, the resulting structures match what we see today, a vast, interconnected web. Piece by piece, these techniques are building the most detailed 3D map ever attempted, one that stretches across nearly the entire observable universe. And the more we map, the clearer the picture becomes. We are living inside an immense structure, a web so vast that even the largest galaxy clusters are just tiny knots in its threads. But the real question is, why does this structure matter? What secrets can it reveal about the past and the future of the universe? It's easy to think of the cosmic web as just a pretty picture, a cosmic piece of abstract art. But for astronomers, it's far more than that. The web holds answers to some of the deepest questions about the universe itself. First, the cosmic web is a laboratory for dark matter. Remember, we can't see dark matter directly, but the web is shaped by it. By studying how galaxies trace those invisible filaments, scientists can test different models of what dark matter might be. Some theories predict smoother filaments, others predict clumpier, denser threads. The more accurately we map the web, the closer we get to unlocking the identity of the universe's most mysterious substance. Second, the web gives us clues about dark energy, the force driving the universe's accelerated expansion. By comparing how the web looked billions of years ago versus today, astronomers can measure how quickly galaxies have been pulled apart. That cosmic tug-of-war between gravity and expansion may hold the key to predicting the ultimate fate of the universe. Third, the cosmic web challenges us with scale. The largest filaments span billions of light years. The voids are so huge they dwarf entire superclusters. Yet zoom in far enough and you find galaxies, stars, planets, and us. This layered structure forces us to confront the humbling truth. We are woven into something much bigger than ourselves. And then there is the philosophical side. The web isn't random. It has order, symmetry, and beauty. Some scientists even argue that the structure resembles neural networks in the human brain. Could it be coincidence, or is there a deeper principle at work where the universe organizes itself in repeating patterns? By studying the cosmic web, we are not just learning about galaxies, we are learning about the blueprint of the cosmos, the hidden threads that connect everything. It's a reminder that while we may feel small and isolated, we are quite literally part of the fabric of the universe. We began our journey by zooming out, step by step, until even galaxies themselves became points of light. And what we found wasn't chaos, but structure. A vast web stretching across the cosmos, filaments of galaxies, knots of clusters, and oceans of emptiness in between. The cosmic web is the universe's skeleton, and it tells the story of how everything we see came to be. From the earliest moments after the Big Bang, invisible dark matter began pulling matter into place. Over billions of years, this scaffolding guided galaxies into their threads and walls, shaping the cosmos into the breathtaking structure we see today. But the web isn't just history, it's also a tool. It's helping scientists probe the mysteries of dark matter and dark energy, two forces that still defy explanation. And beyond the science, there is perspective. When you look at the cosmic web, you see a pattern that repeats across scales. Cells, neurons, spiderwebs, and galaxies. The universe is stitched together by threads that look awfully familiar. It's as if nature has one great design principle echoing itself from the microscopic to the cosmic. Standing on our tiny planet, it's easy to feel small, even insignificant. But zoom out far enough and you realize something profound. We are not separate from the web, we are part of it. Our atoms were forged in stars, carried in galaxies, woven into filaments billions of light years long. We are the universe looking back at itself, one thread among billions in the grand design of everything. Thank you for watching, keep looking up.